In this video we are going to cover review exercise 5 at the end of tutorial 5 on pages 458 through 462 in the text. As always, I highly recommend that you first take significant time with this drawing to try to understand the geometric features as they are related to one another and the way they relate to the dimensions you are given on the prints. This way you can strategize about how to begin building your part geometry. And having done this, I first see a lot of circle center points I can start with, so I'm going to begin building those. Go to circle center point. My outer diameter of my part is 5 inches. Place that on center, accept it. The inside, or the ID, is 4.75 inches. I'm getting this off of the top section view there. Enter 4.75, and there I have my ID. Accept that. Now I move down to the sort of the front view, and I see I have a diameter of 4.5, which represents the outer portion of all of these slots. So I'm going to put the 4.5 in. There we have that. I also have a 2.75 diameter that looks to represent the center line on which all of the nose radiuses, which are all 0.125, they are placed. So accept that. I'm going to put in that 2.75 and place that one. Before I actually accept it up here, I'm going to change the line type so that I know it's a construction line just for visual purposes. And technically we don't really need them because we really just need to know the radius, because that's what we're going to use for coordinates. But I think it's a good idea to pop them in. Help you when you rotate, make sure you're placing everything correctly. We'll take that one. We also have a bolt circle with a 1.75 diameter that our lug bolts will be placed on the holes. So there we have that one. We're going to apply it. And I also see a 1-inch hole. I'm going to go back to my old line type. I've got a 1-inch hole through this wheel. And we'll place that as well. I can accept that. I also see that I've got a lug hole and one of the noses of my slots sitting on the x-axis, so I can use those diameters combined with the fast point coordinate locations to place those and then build around them. So I've got a lug hole of 0.375, and it's going to be placed on fast point. X will be the bolt circle diameter is 1.75, but we're going to divide it by 2 because we only need the radius, comma, and the y is 0. Enter. That looks like it went right in there. It's on the x-axis and it's centered on that bolt circle. We'll accept that. I've also got the nose of one of these geometric profile slots to go in. We're given a radius of 0.125 based on that drawing over on to the side, the right side there. And our fast point location in the X is the 2.75 construction circle, so 2.75, again divided by 2 for the radius, comma, y is 0, enter, and that looks placed in the correct position as well, based on the detail AA drawing. Apply it, and I think that's all the circles we have for now. At this point I can clear colors. There, they are cleared because I'm drawing in purple. So we can put in a line endpoint. Again, I'm focusing on detail AA drawing. I have a line endpoint that's basically just a horizontal line. I need something on the x-axis to parallel from. I'm just going to pop that in and accept it. Check out. And I'm going to parallel off of it. The parallel distance, looking at the drawing, is 0.28. And this line to this line. Check out of that. Again, looking at this same detail drawing, I've got a 5-degree angle coming off of what looks to be the intersection of this 4.5 circle and this 2.8 intersection. So I'm going to create a line endpoint, put it from that intersection. I'm going to have to turn off horizontal from here, and then I'm going to, it needs to be 5 degrees. I'm going to put in 180 minus 5, which is 175, hit enter, and then just place it out here somewhere. And accept that. I've also got a 5-degree angle, but it's 50-degree angle, but it's 50 degrees off the y-axis, and we're working off the x-axis. We always start at 3 o'clock and work around, so that would make it a 40-degree angle, the way MasterCam's going to be reading it. So I'm going to put one in at 40 as well. It's also going to be a tangent line endpoint. I'm going to get a little closer so I can control this. Picking this one, I almost picked the lug bolt. This is my nose. And we're at 40, so I can just drop it in. And that's exactly what we want. I can check out of that now. I can put my fillet in. Radius is 375 for this fillet. Enter, and it'll take care of trimming and everything as well. I can also delete these construction lines now, and I'm ready to mirror image it. So I go to X-Form, Mirror, hold down the Shift key, and pick this, Chain, End Selection. I want to copy it about the X-axis, which is this one. Now it's saying select a reference point. This would be no good. What I need to, otherwise it would cut my nose off. I need to pick this reference point to rotate about, and that looks good. At this point I can trim. I like trim divide for this. Clean this out. And it proves to you that you're tangent because it sees an intersection there. If it didn't trim right, you'll know you're not tangent like you need to be. And now I'm going to put these back radiuses in as well. Check out of that. Fillet radius. These are 125s. I don't want to trim the first one or it'll get rid of my whole 4.5 circle, so I want to leave it in there for the second trim fillet. So there's that one. Now I'm going to put the trim back on. See, at least I have a little piece of that I can fillet to now. And put another one in right here. And there we have our geometry for that pentagonal slot. Check out of that. This would be a good time to do some rotating. We have two things we can rotate now. The first one is the lug bolt hole. X-Form, rotate, pick this lug bolt, and selection. We are copying these. total of 5. So we really don't know what the angle is, so we just go total sweep 360 all the way around, total of 5. And look, they gave you a preview. It's exactly what we want. And check out of that. I'm going to go to X-Form, rotate again. I'm going to hit my Shift key and pick this chain, end selection, copy. This time there are 6 of these, total sweep, 360. We know that that's 60 degrees between them, but we didn't even need to think about it. Check out of that. At this point, we can probably get rid of these 2 construction circles, but they have verified that we have done everything the right way. Everything's consistently rotating around them. But I can get rid of them now. And there we have all of our slots. Now, based on the way the print is dimensioned, which is why I tell you to look at it and sort of plan the way you're going to assemble your part geometry, is because at the bottom, detail BB, this triangular slot, if you will, is simply paralleled off of the other slot that we just created. So we can pick any of these, but basically the way I'm going to begin building that is off of these parallel lines here and here. So go to parallel line. The distance we are given off the print at the bottom is 0.1875. Enter. I need a line from here, and I need one here. The other thing I need to do, I'm going to check out of that, is put my 4.5-inch circle back in, because it also applies to the back edge of the slot, the triangular slots. So I'm going to create a circle, 4.5 inches, drop that in on center. Now I'm going to check out of that, get my scissors, trim and extend one entity. I want to trim that to there. This doesn't look right. I'm going to go ahead and put that back in again. Parallel. It looks like I lost my 1.875 along the way. There to there. Okay, that looks better. Back to my scissors. Trim and extend from here to here. I can also extend them this direction by just putting in like a 0.75, 3/4 of an inch distance, and picking here and here. That way I've got something to fill it with, which is exactly what I'm going to do. Looking at my print, I have 3 fillets of 0.125. Go to fillet, 125. Put the easy one in first. You're right here and here. And then I'm going to go here and here, and here and here. It trimmed everything, put the fillets in just perfectly. Now we just need to rotate it and copy it. So I go to X-Form Rotate, hold down the Shift key, pick this chain, end selection, copy, 6 total, 360 degrees, and there they are, and they look perfect. So at this point, all we need to do is set everything in the Z-axis. We've got all our geometry in there. So we need to X-Form translate the 2 outer rims, the OD and the ID, and selection. Going to our print, these are copied, one copy at Z -1.5 inches, and there we have some thickness to our wheel. Back to top view, I need to set all of these slots and these lug holes and even this hole in the middle down into the wheel by 0.125. So I'm going to go to Xform Translate, and I don't have to pick these all individually. The way these boxes work is as long as I get all of something in there, it will select it. If I leave a little piece of something out, it won't select it. So my box is going to try to encompass all of the slots and everything interior from there, and leave at least one or two pieces out of this and this because I don't want these selected. So I'm kind of lining myself up outside of here and outside of here, and I'm going to drag that box, make sure I get all of my slots, but leave at least a piece of each of those outer rings excluded. Click it, look, it select everything exactly the way we wanted it to. End selection or enter. This time we're actually moving, and we're going Z -125. Flip it up, see that it has in fact done so, and we can check out of that. Isometric fit, there's our wheel. At this time we are ready to start setting up a machine and doing some machining operations. So now we go up to our machine type, pick our default mill, set up our stock and our tool settings. I'm going to put 9 in here because this is the 9th job. Check all the usual boxes. Have a lot to do with our program and the way it's going to generate code. This is cylindrical stock. You can put a display on if you like, wireframe or solid. It's based in the Z. The thickness is 1.5. The diameter is 5. And we need to check all entities. Notice it put a value in here. So we have that going. Toolpaths, we're going to stick to the 2D high-speed machining style. Go to area, put your name in here. Chain is already activated. Pick this interior chain here. I'm going to face this. Check that. Single region is yes, check that. It's area mill. The tool, we need a 1-inch flat end mill equal to 1. Pick that. Face the part. Cut parameters. Everything looks fine there, except we're not going to leave any stock anywhere. We don't need depth cuts or that, or breakthrough. All I need to do is go to linking parameters, set my standard offsets. This is the clearance for the clamps and things, 2. That looks good, that looks good. Top of stock is 0, and our depth is -0.125, which I've taken from our drawing. Check out of that, and we can backplot it. That looks good. Moving on to our contoured slots, I'm going to go to Toolpaths, 2D high speed, dynamic area, pick a chain. I'm going to go to front view and fit. I'm going to pick this chain and reverse it. I'm only going to pick one chain instead of 6 and then transform it from there. I didn't really like the way they did it in the previous tutorial, but I know they did that to show you stuff. I'm just going to go with my single chain and set up this whole job here. Dynamic area, the tool is going to be a 1/4 inch and mill. I'm going to select that. Oops. I got to go back to machine, triangle, and this is a through. Cut parameters. Again, we're not leaving any stock, otherwise the defaults are fine. We're not to use depth cuts here. Entry motion, be the profile. Go ahead and check that. I'm going to put a breakthrough on here because technically once we mill out the underneath it will be broken through, so we want to make sure we've cleared. Just about 30 be fine. Linking parameters. All our standards. Our top of stock has now become negative 0.125 because we faced that interior area and we don't want to waste time milling air. Our print dimension on this is absolute, negative 0.5, and again the breakthrough will give you the extra that you need, insurance, so you can check out of that. We can backplot that operation as well. Looks good. Let's do another one. Toolpath, 2D high speed, dynamic area. Chain is on. I'm going to pick this chain. And I had some rhyme and reason to my chain selection processes. I'm going counterclockwise and one next to the other because intuitively the machine sees this as 60, 60, 60. Going the other way, it's negative 60. So it thinks in terms of counterclockwise, angular motion. And also, I'm going to pick the order so that I'd go from this one to this one to this one to this one instead of jumping around. So I'm thinking ahead on that. Pick the chain. Single region, yes. Set everything up. Toolpath type, dynamic area. The tool is the 1/4 inch. I'm going to machine the pentagonal shape. My cut parameters all look good. Put depth cuts on here along with a finish cut because it is a blind pocket. We'll go with 0.1 for the maximum cut, one finish cut, and a finish step to 0.01. Everything else looks good. Entry motion again will be the profile and all the defaults. Breakthrough we will disable because this is blind. Linking parameters, clearance is 2 to the 1/4 inch, 0.1, those are right. Top of stock is absolute negative 1.25, and my depth, if you look at the print, it's dimensioned incrementally at negative 0.1875. And we'll go ahead and backplot that one. See how it's doing the profile? Okay, so now I have two really good operations set up here. I'm just going to copy them, each of them. So I go to Toolpaths, Transform, Rotate, Operation Order. That's how I'll get them to go from one to the other to the other to the other, instead of doing like operations first and then all the other like ones. I need to put my control key down and pick 2 and 3, copy them, and disable the initial operations because we don't want redundancy. Now pick my rotate tab. This is the time where 5 copies actually works. We're not doing total sweep, we're doing angle between, so that's part of it as well. And then basically we're going to start at 60 degrees and then go with increments of 60 degrees for each copy. So let's take a look at that one. See how this ghost says we shut off, we disabled the code from these because it's all taken care of down here. Going to do a quick back plot. And just make sure it's following the way I want it to. That has a lot to do with those radio buttons. Like I said, I could, if I were to switch tools or something, then I may want to go with like profiles first, and then do all the triangles and then all the pentagons or however. But that looks good. I'm going to show you one more time where that lives. Operation order made me go from one to the next. Operation type would make me do all the triangles and then all the pentagons. But everything is good, so I'm going to pick everything and verify it. Isometric and fit. Now here we go. We face. Pick up the speed a little bit. Very good. Now we're ready to take care of drilling and circle milling the holes. So to do that, we go up to Toolpath Drill, pick entities. I'm going to switch to the front view and pick these 5 lug holes, and selection. It is a drill cycle. The tool is a 1/2 inch spot drill. I'm going to spot drill. The lug holes. Cut parameters. It is a drill counterbore cycle, meaning it is just going to blow straight down into the part. I want a little 1-second dwell just to make sure it makes it all the way around, and we have a nice little chamfer there. My linking parameters are absolute 2. These all look good. Top of stock, however, is still our negative 0.125. And our depth is going to depend on the chamfer we want. Now there's no chamfer called out on the print, but we did use one for the tutorial, and there wasn't one called out there. So I just want to put a tiny one in. Very rarely do you have a hole without some type of lead in on it. So my tool diameter is 0.5. I want my finished diameter to be 0.4, being that my hole is 0.375. That gives me just a little bit, total of 25 thousandths, so the chamfer itself is going to be like 12. And we're going to add it to the depth. Check that. And we need to do it incrementally because we're already down from the face of the part, so we don't need tip comp, and we can check that. Before I backplot it, I'm going to put the drill cycle in as well because I need to face the part to see if my chamfers and everything are correct. So instead of running all of that, I'm going to gamble and go to Toolpath, Drill, Last. This is a drill cycle. The tool is the 3/8 drill. Drill the holes. Cut parameters. Here we want a little bit of a peck because we're going to go down like a 1/2 inch. So we're going to peck at every 100. The linking parameters. Top of stock again is negative 0.125. We don't want to bother drilling air. And our depth, actually this time, as it's dimensioned on the drawing, it's absolute -0.5. We do want to put tip comp in this time. And that looks good. Okay, so we selected everything. Now we'll generate. Bit and isometric. Going to want to run everything just to make sure that my chamfers come out correctly. I have to have this stock faced off in order to do that. Nice little chamfer. See, there's our 375, and then we picked 400 for an overall width, which gave us about 12.5 thousandths chamfer, and we selected incremental from the -0.125 height, so that worked out really well. The holes look good. Now we can circle mill that center hole. I want to go to Toolpaths, Circle Path, Circle Mill, Entities, and pick this circle. Toolpath type is Circle Mill. The tool is the 1/4 inch flat end mill. I'm going to mill center. Cut parameters. Basically, we're not leaving any stock. We are asked to enable roughing this time, and it makes sense because otherwise our mill's so small we'll have this little island in the middle. Finishing. One finish cut at 20 thousandths. And I'm just going to finish the walls at the very final depth. No transitions. Depth cuts. Maximum rough step of 25 thousandths. And there, I'm going to put a little breakthrough on here just to make sure, so when I come back and clean up, because technically this is a through hole, that it'll be nice and clean. So I'm going to go 30 on the breakthrough. Our top of stock is still -0.125. Our depth is absolute -0.5, just like all the other through stuff. And that looks good. I'm going to verify it for what that's worth. Okay, so now all we have left to do is to flip the part up over and clean up the bottom. So in order to do that, I'm going to have two toolpath groups. So before I forget, I'm going to right click on this one and pick Edit Selected Operations and change the NC file name. And I'm going to change it to Setup number 1. Didn't seem to take. I'll try it later. I had the same problem before. For machine group, I'm going to right click, Groups. I want to add a new toolpath group. It's down here now, and this one will be set up too. Click on WCX and the View Manager, pick bottom, equal, and a Z of 1.5, and check that. Now when I go to my top view and my isometric view, I can see that everything is reversed. I'll do an isometric fit, and that my Z is actually up here. So at this point, all we need to do now is to clear out the bottom using Toolpath. Choose the high speed dynamic area. Click that. Pick the chain. We're going to pick this inside ID. I like to reverse it. Looks good. Yes, it's a single region. There are no islands or anything, or different pools of material. Dynamic area mill. The tool is the 1-inch flat end mill. We're going to machine the bottom. Cut parameters. Not leaving any stock. Everything looks good there. Disable depth cuts. Entry motion. Go with helix only. There is no breakthrough on here because we're going to a set depth. Linking parameters. Top of stock is back to 0, and the depth on this is an absolute -1. And that should do it. Verify this operation. So far so good. I'm going to go back to my top view now. And fit and isometric, so things are back to normal. I can flip it while we're in the animation window to show you how it works out the bottom, but I like to have it this way in terms of storage. Okay, so let's generate the entire thing and verify. So slow it down. I'm going to speed it up here. You can move it around while it's animating. That's our blind pocket. Finishing the bottom. You can move this around just like anything else. See, all our little breakthroughs are paying off because now when we go to depth, it's all nice and clean. Flip it back around. My chamfers look good. So that's what you need to do. Good luck.